For this example, we're going to do a couple more function operations. We are given two functions, f of x is equal to 7x plus 10, and g of x is equal to x squared plus 3. The first part asks us to please find f times g of x. This is the same as saying f of x times g of x. This is really similar to when we do the addition and subtraction, and we're going to want to keep the functions in parentheses like before. So my f of x is 7x plus 10, and my g of x is x squared plus 3. And now we simply FOIL to get our result. So 7x times x squared will be 7x to the third. 7x times 3 is 21x. 10 times x squared would be 10x squared. And 3 times 10 would be 30. And since we had no like terms, we can go ahead and box this as our final answer. That would be a multiplication example. Probably the most difficult part of this section is the actual composition, and that's the second part here. And we say that this is f of g of x. And the book rewrites this as f of g of x. Now in function notation, whatever's in the parenthesis, like this x up here, is whatever we put into our equation. So since g of x is in the parentheses for f, we're going to put the value of g of x into the function f. So I'm going to go ahead and rewrite this as f of x squared plus 3, because g of x is x squared plus 3. So now, like I said, this is our input. So we're going to put this everywhere that there is an x in f of x. And that gets a little confusing because of this is also an x. But you could almost think of this as an empty box. And whatever's in those parentheses, we're going to put in that box. So I'm going to put in f of x plus 3 is equal to 7 times whatever our input is, which in this case is x squared plus 3, and then plus 10. Now I'm going to go ahead and distribute that 7 so that I get 7x squared plus 21, and then plus 10. And combining like terms gives me 7x squared plus 31. I will go ahead and do a couple more examples on the next file.